Hi students, welcome all to this new video. Here we are going to discuss about a named oxidation reaction, that is Baeyer Villiger Oxidation reaction. This reaction is named after Adolf von Baeyer and Victor Villiger. There's two scientists. This reaction is named after them. Then what is Baeyer Villiger oxidation is? That is the oxidation of ketones to esters. Okay, this is acetophenone. This is acetophenone is on reaction with the paracids like PHCOOH is a peroxide in presence of CHCl3 chloroform. An oxygen is inserted here. An oxygen is inserted here and form an ester. Okay. This is an ester and this is a ketone. Okay, then ketone gives esters by insertion of oxygen by Baeyer Villiger oxidation reaction. The reagent used is peracids. Okay, peroxyacids or peracid as the reagents. Okay, what is the mechanism of Baeyer Villiger oxidation? We are going to check the mechanism. Okay, mechanism of Baeyer Villiger oxidation reaction. In the first step, consider a ketone. If this is the ketone RCOOR. In the first step, the protonation occurs. That is, protonation on this carbonyl oxygen is a protonation step. So this is like this RCOH plus R. Okay. First step, the protonation of ketone. In the next step, this protonated ketone, the R dash COOH. One of the peracid adds this protonated ketone in the second step. So the product formed will be here H plus leaves, this H plus leaves, and then R dash COO minus adds towards this one, R dash COO minus adds towards this one. At the same time, this bond leaves like this, that may be like this attacks on this carbon and this bond shift like this. So R, C, here OH, then here R, to this one this O and O, then COR dash. This peracid adds towards this carbon and a tetrahedral intermediate is formed. Here forms a tetrahedral intermediate, and in this tetrahedral intermediate consider a concerted reaction, that is the migration of one of the alkyl group depending upon the migrating aptitude is migrates towards this oxygen, and the carboxylate ion R dash COO minus group leaves from here. At the same time, one of the lone pair of electron moves like this. Okay, so the product formed from this intermediate is R, C, here double bond OH plus, okay, this one of the lone pair moves towards one, so double bond comes here, a positive charge here, and here this R migrates towards this oxygen, onto this oxygen, so O and R plus this R dash COO minus carboxylate group R dash COO minus leaves from this intermediate tetrahedral intermediate compound. Okay, in the next step, this one of the proton, that is the proton from here, this is the proton, it leaves by this one of the H plus leaves from here and forms R C O O R. So this is the ester formed here. This is the mechanism of Baeyer Villiger oxidation reaction, in which a ketone gives an ester as the product. First step, the protonation of ketone. The second step, the peracid, one of the peracid adds towards this one, okay, like this, and tetrahedral intermediate is formed. In this tetrahedral intermediate, through a concerted mechanism, an alkyl shift and occurs, and also the carboxylate ion R-CO minus leaves from the molecule, and in the next step one of the proton leaves and gives the ester as the product RCOOR. Okay, this is the mechanism. And here if you isotopically label this one as O18, this is oxygen 18 is, if it is you label isotopically, you can find that is O18, here is O18, here this one is O18, and this one is O18. This isotopic labeling suggests that the carbonyl oxygen of ketones becomes the carbonyl oxygen of the ester. Okay, here the carbonyl oxygen of carbonyl oxygen of the ester is the same as the carbonyl oxygen in the ketone. By isotopically label you can prove this one. Next, here a migration of alkyl group takes place. The order of migration, that is aryl group migrate faster. Okay, aryl group migrates more than alkyl group. In case of alkyl groups, tertiary groups migrates faster than secondary, then primary, then methyl group. Okay, you must remember this order of migration of this group. Okay, if this is an aryl group, it has the more migrating tendency than tertiary. This is a alkyl groups, tertiary has the more tendency, then secondary, then primary, then leastly for methyl group to migrate. In case of aryl group, consider these three examples. If OCH3, this group migrate faster than this group, and this migrate faster than this one, NO2. Okay, this is an order of migrating aptitude of aryl groups. Okay, this is the order of aryl groups. Simple three examples. This is the order of migrating aptitude of aryl groups. Next, some examples for this Baeyer Villiger oxidation reaction. First example, consider this compound. This is NO2. Okay, here see double bond O, then say ketone. Okay, this one reaction with CH3 COOH, say paracid, in presence of ACOH and H2SO4 sulfuric acid. The product formed will be this one. Here NO2, one of the oxygen is inserted to, between this group, COO, here the phenyl. Okay, this will be the product. Here this group migrates than this one. Okay, so this product is formed here. Remember, Baeyer Villiger oxidation has great synthetic importance. It also works for cyclic ketones also. Okay, it works for cyclic ketones also. For example, this one, consider this one, this ketone. Okay, if it is on reaction with a CF3COOH, okay, is a paracid, this will form a product. The product will be like this. Okay, that is one of the oxygen is inserted between this carbon and this oxygen atom and form the product like that. Next example, a 1,2 diketone, that is CH3COCOCH3 is a 1,2 diketone. It's on reaction with a paracid like CF3COOH. It forms an anhydride. That is, one of the oxygen is inserted between this oxygen, this carbonyl group. So the product formed will be this one, RCOCH3. That is here an anhydride is the product formed by the reaction of a diketone with a peracid. Another example for Baeyer Villiger oxidation, consider this compound, this ketone, Okay, this is CH3 here. Here, if it is on reaction with a CH3, COOH, a paracid, and ACOH, here the product formed will be this one. Okay, here CH3, and this the oxygen is inserted between this carbon and this carbon, this CO and this carbon, because it's a tertiary group is here. Okay, so the product formed will be here this group C double bond O, and the oxygen is inserted between this CO and this one. Okay, so these are some examples, mechanism, and the explanation of Baeyer Villiger oxidation. This reaction has very high synthetic importance, in which a ketone is converted into an ester. Okay, this is all about Baeyer Villiger oxidation reactions. Thank you.